Welcome back, everybody. Welcome back to another fun weekend. All right, got the coffee, got the airplane, got beautiful weather. What more can we ask for? Let's go. Time for fun. Here we go again. Another Stig Shift. Welcome back, everybody. Let's go have some fun. We got a lot to talk about. That thing just pulled in right there, so got a little jet blast happening. This is the CFM LEAP 1A. We're looking at the high bypass, and you'll notice lots of little holes all over the place on the walls, right? The primary reason for the holes is to reduce engine noise. You'll see this on a variety of modern engines. Let's stop here for a second, and I want you to pay attention to those little openings right there. These are called VBV, Variable Bleed Valve. This is part of the compressor control. The main function of the VBV system is to control the airflow injected into the HPC, high pressure compressor. When it takes air in, it increases the booster surge margin. In simple terms, it prevents any kind of stall or surge within the engine compressor. Here's another example on its older model engine. This is the CFM 56-5B, and as you can see right here, the doors and the little openings right there. There's 8 of them altogether. Just to make mention, there's 2 other compressor controllers that help the engine with this kind of system. One is the VBV that we just saw. The other one is the VSV, variable stator vanes, and TBV, transient bleed valve. All of these units assist in optimal performance for the compressor section. So those 2 circles, underneath those 2 circles actually, are the main fuel pumps. There's 4 of them, 2 per wing. Main purpose is to supply fuel to the engine with positive pressure. If one fails, the other one can do the job just as good. If both fail, still okay, because the wing is designed in such a way where the engine will still get fuel via gravity. There's 2 more components to this which are in the center tank, but they're not actually fuel pumps. They're called jet pumps. They work on a Venturi system. So the way this works is, let's say the aircraft is fully fueled. All wing tanks, center tank, and ACT tanks, additional center tanks, all full of fuel. Process goes like this: ACT tank to center tank to wing tanks, and wing tank to the engine. There's also a system called a crossfeed, where you can crossfeed one wing tank to the opposing engine. Just remember, we're talking about the Airbus family, the 320 family. Here's a good look at what the actual fuel pump looks like. It sits within a canister, and a canister is within the wing. So to make mention, these are electric driven pumps, which brings me to this. Do you see those 2 lines or 2 stripes that are leading away from the pump itself? Those are the electrical connectors, or the wiring. In order to prevent any kind of spark or any kind of wiring deterioration within the tank, Airbus decided to place the wiring outside of the tank. As I was doing my walk around, I noticed one of the tethers that holds the door kind of sticking out. I decided to open the panel, so put it back in properly, but it gives me an opportunity to show you what's in this compartment. This is on the belly on the left-hand side, and the first thing you can notice here is onto the corner is the accumulator. That provides head pressure to the blue system reservoir. Right next to it is the actual blue electric pump. As we focus our attention to this side, that is the RAT, the ram air turbine tucked up. This is when it's stowed into the aircraft. The RAT is what provides power to the blue hydraulic pump. I've made a video about the RAT. If you got time, go check it out, guys. Check it out! You see that? Those are one of them is a oval wing exit hatch. It was very loud, so let me just explain right here what I'm talking about. That's an oval wing exit hatch. Notice there's 2 of them, but only one of them is usable. The other one is simply a plug. The reason they do this is because of seating configuration. Let's say if the aircraft was configured with more seat, more densely packed, you're going to need more exits. More seats equals more passengers. That means you need more exit doors or hatches. Hey, how about that? Look at this beautiful 747-8. Gorgeous. Wait, wasn't this the one that had the hard landing a couple of weeks back or a week back? And yep, I was right. It is the same aircraft. This was caught by Airline Videos. They are incredible. Kevin and Rudy are good friends, and they always catch the best stuff on YouTube as well as Instagram. Go check them out. But this is what I want to show you right here. And I want to tell you what we do as maintenance when this happens. Again, hard landing, and pilots go ahead, chime in, what are the factors and why this kind of thing happens. But this is my perspective of what we do after this happens. A very detailed inspection needs to be done. First and foremost, we have to pull up any kind of associated paperwork that's related to a hard landing. Then we have to debrief the pilots, find out what actually occurred. I know this is not a 747, but I'm just using it as an example. The first thing we do is inspect the wheel wells. We want to make sure there's no damage within the components. Anything in there, we have to inspect thoroughly. Along with the walk around, we will drop the flaps of the aircraft. The flap system within aircraft are very intricate and they have lots of linkages within them. Many transmissions, torque tubes, and all these vital components such as flap track slats and roller carriages, all those things need to be inspected for damage. See, when an aircraft lands with such a great amount of G-forces, those linkages and those components can be damaged. So we go through all of those things and we make sure there is no deterioration or any kind of broken things, basically. You know, all this being said, believe it or not, aircraft are very resilient. They're very tough. It's able to withstand that kind of punishment, but we still have to do the inspection. Once we get done with the exterior inspection and a proper walk around, then we focus our attention to the aircraft parameters, as in the logic and what it's reading. What we're looking for is the G-load factors. The aircraft records that. If there's an excessive G-load onto the aircraft, it does record that specific parameter. If the G-load factor is exceeded, then we have to go to a different set of manuals. At that point, we're contacting the manufacturer itself because now we have a potential breaking of the wing spars. Everybody remember this incident with Alaska, with the 737? They landed so hard that the strut went through the whole wing. Now, if something like this happens, that's it. It's over. Airplane is grounded indefinitely. Going back to the 747, yeah, that thing bounced pretty hard. Twice. They decided to do a rejected landing and do a go-around and come back and land once again. I'm sure the technicians performed an inspection. If everything was broken or anything was broken, they repaired it and the aircraft was back into service, because a couple of days later, or excuse me, a week later, I saw it once again, and that's what you saw when I was, referring to. I think this is the one. Well, looks like it's fine and dandy. Still flying around. Cool. A moment to enjoy some airplanes landing and taxiing around. A beautiful A380 from Lufthansa coming down right there. But that wasn't the only special aircraft. There's something actually really special that came into LAX this weekend. That's right there. The Antonov 124 came in. Don't worry, on lunch break, we're going to go over and check it out. Next office, back to 37. 3X? Had 3Xs? Man. All right, let's see how we're doing over here. As standard, do a quick little walk around. Is everything okay? A little dirty, but it's all right. It's normal. A quick little overview on the nose landing gear wheel well and the nose landing gear itself for the 737. Those big cylinders that you're seeing are the nose steering actuators. Yes, the hydraulics do move the nose steering on this aircraft, but it is still controlled by a direct control cable. It is cable driven, hydraulically assisted. Thing with the orange cap is the Schrader valve. That is how we service the nose landing gear strut, and that right there is the uplock actuator. Way up top over there, that is actually the release for the manual drop. The big actuator is the primary actuator that brings the nose gear up and down. Those brown components that you're seeing, that is the nose wheel stoppers. And then over here on this side, you see that little circle right there at the top? That is the horn. Made a whole video just for the horn. Brakes and tires looking nice and healthy. This thing just came in from Vegas, and I believe it's going back out to Phoenix. I don't need the light. This is what the inside of my brain looks like. I'm just joking. I remember somebody in the comments asking, can you give a description of some components on a 737 main landing gear or the main wheel well? So here we go. Just to note, this is just some of the components. I cannot go over all of them. There's just too many. It would take me a week at least just talking nonstop to explain what's going on in this wheel well. What you're looking at there is a fuel pump. Boeing likes to call them boost pumps. That's on the left wing, the aft one. Remember, there's two per wing. As we keep moving, we take a look up there and we see two massive actuators. Those are the aileron autopilot actuators. Once again, Cable driven, as in physical cable, control cable driven, hydraulically assisted. It's only on the 737 MAX where the spoilers became fly-by-wire. Anything below the 737 MAX and below that generation is still all cable driven, hydraulically assisted. Up next, we have the hydraulic pressurization module for System A. Remember, Boeing 737 have 3 hydraulic systems, System A, System B, and a reserve. In simple terms, it regulates the hydraulic pressure. Up next, near the keel beam, you're going to find the thrust reverser control valve module. There's 2 of them, one on each side. These units send hydraulic power to the thrust reverser hydraulic actuators. The handle I pointed to is there to deactivate them when needed. Up next, we're going to take a look at the hydraulic System A electric pump right there. Okay, I'm going to pause this right here to address something because I know it's going to get brought up. Okay, I know it's dirty. I know it looks like it's leaking. It's not, guys. These are not active leaks. This is seepage. Seepage with an aircraft is allowed. What's not allowed is active leaks. When you see something very dirty, smothered with old hydraulic fluid, which turns yellow, which what you were seeing right there, that's okay. What we're worried about is active fluid leaks. Otherwise, seepage is normal wear and tear. Remember, these systems are under extreme pressure, 3,000 psi. Not only that, the aircraft goes up and down in altitude. You also have external pressure. On top of that, you have massive amount of temperature change from very cold to very hot. It's expected to leak. But once again, not an active leak. I hope you understand this. So just because it's very dirty, very messy, yeah, that's just the way aircraft are. They're very dirty and very messy, and things seem to, they seep. Fluid seeps. That's just the way it works. My point being is that when you see this stuff, please don't panic. Airplane is not leaking out fluid. It's just seeping things out. This is why we're always paying attention to fluid levels. If it gets low, we replenish. If there's a leak, we will address the situation. Okay, let's keep moving. Electric System A hydraulic pump and Electric System B hydraulic pump. Right below those things, those cylindrical things right there that you're seeing in a diagonal orientation, those things are called acoustic dampeners. They reduce noise from the hydraulic system. Up next, we have a PTU, power transfer unit. That's right, the 737 also has one, but this one doesn't bark like the one on Airbus. So the way the PTU works on a 737 is slightly different than it works on an Airbus. The concept is the same. It provides alternative source of hydraulic power. But when it comes down to the 737, it only is specific to certain things, only to the leading edge flaps and slats only. The unit can be used in normal operations or for auto slat operations when System B engine-driven pump, the EDP, is below normal pressure. It's basically there as a backup in case you lose a system. You want to make sure you still have functionality of your flaps and slats. Anyway, moving on. As we keep moving up the center keel beam, you'll notice these components right here. This again deals with the ailerons. These are called pogo inputs. The center shaft on the left-hand side right there is the input shaft that creates the maneuverability for the ailerons. Ties directly, once again, back into physical cables. The job of these little pogo things, or they call them pogo, they actually are called pogo, which is hilarious. What they actually do is they transmit the input from the input shaft to the aileron PCU, the power control units. That's why there's 4 of them. 2 for System A, 2 for System B. Once those things are starting to maneuver, the aileron body quadrant will start moving because that crescent moon shaped big white bar right there, there's 2 of them, top and bottom, those will move the aileron body quadrant. This is as easy as I can make it. I'm sorry. If I keep diving too deep into this, your brain is going to melt and so is mine. So let's keep moving. Up next is the hydraulic reservoir, the Reservoir A and Reservoir B. But remember, I told you, this aircraft has actually 3 hydraulic systems. This is the reserve reservoir. Okay, we keep on going with flight control surfaces. What you're looking at right there is the power drive unit. This is looking aft from the keel beam, and attached to the power drive unit is the hydraulic motor. I did a horrible job getting the imagery on this one, but take a look at the top left corner. Do you see that little green box right there? That is called the flap control unit. So there are cables coming down from the flap lever and they go to that flap control unit. That in turn goes through a flap control valve. Then it sends system B hydraulic power to the bypass valve, then goes to the hydraulic motor, and then it powers the power drive unit. And this is how you're able to lower and raise your flaps. You can do it hydraulically or you can do it electrically. The electrical portion is obviously the backup. I think that's about enough for today for the 737 wheel well. I don't want to overwhelm you. Let's keep going. If you were wondering what that sound was, those are the hydraulic pumps. The hydraulic pumps running. The electric hydraulic pumps. Yeah. Pretty loud when you're in wheel well of the 737. Got a moment to enjoy some airplanes rolling around, and this beautiful thing right here, this is a beautiful A330 from Condor rolling around. Check out that paint job. It always reminds me of a pair of socks for some reason. Anyway, let's go see what we got. What, we thought we were not going to come over here and take a look at it? Of course we are. There she is, the beautiful Antonov. Look at that. I think this is the third time we've seen it. Oh, I've seen it here. Pretty cool, huh? You guys know that this thing actually flies with its own tow bar? It's a very special tow bar just for this airplane. Look at this thing. It's just nuts. How cool is that? They're here for. They must be delivering something really big. So a few friends of mine got a hold of me and they actually let me know why this thing was here. The Antonov was delivering SpaceX components for a launch that was due in Florida. So that's the destination. LAX to Florida for rocket parts, I guess. Any of you that are concerned why I'm getting so close to the aircraft, guys, I am not touching the aircraft. I am just looking at it. I'm observing it. I wish the crew was here, because if they were, I could actually even ask them to go upstairs and look around the airplane. They are more than cordial. They're very happy to show the airplane around. Heck, even some of my colleagues got to go up inside the flight deck. I did not have the chance to do that. But anyway, it was so fun to be around this airplane. Even looking at some of these panels, still has Russian writing on it. That's pretty amazing. I can vaguely identify certain things here within the wheel well. Keel beams, obviously, uplock actuators, actuators that retract the wheels themselves. But I don't know anything about this airplane, so just enjoy the tour, I guess. Wait a minute. Does this thing have brake fans? No way. They look like brake fans. Huh. I did not know that. Or maybe I'm wrong. I don't know what these are. They look like brake fans. Interesting. Thought Airbus is the only one that did this. Shout out to Dunlop. centipede. The engines on this aircraft are Latarov D18 turbofan engines. And the interesting part about this is that when you keep looking at them, they look like a blend of Rolls-Royce, GE, and Pratt & Whitney. Just looking at the spinner itself, the way it's pointed, that's so indicative of a Rolls-Royce design. And then you take a look at the fan blades themselves, almost looks identical to a CF6 engine with the mid-span shrouds. So I don't know where they got their technology or where they gathered the influence for the technology, but it looks very similar. If I'm not mistaken, I believe the back end of this opens up as well. It's always nice to see this thing here. One interesting thing I learned about this aircraft is that the entirety of the main cargo deck is comprised of titanium. Basically, all the floorboards within the aircraft on the main cargo loading side is made out of titanium. That's incredible. From what I understand, the aircraft flies with its own flight crew as well as its own dedicated maintenance crew. It has all the components and everything that it needs for logistic purposes to keep the aircraft moving and flying. It contracts out through all across the world to deliver massive components wherever it needs to go. But it's always beautiful to see this thing. As always, cargo never disappoints. Woo! Look at that. Somebody's getting their brand new Tesla Cybertrucks. We got two of them this time. Look at that. You saw one here last time. Now we're going to see more of them. Really cool. And a nice Carrera too here. Look at that. Gorgeous. Poor little Porsche. Got sandwiched between two Cybertrucks. That's hilarious. Okay, so I guess they do take out the batteries. Or battery powered. I don't know if they take them out or not. Who knows? Look what's hiding over here. Oh, this is special. I know this has got to be special. This is beautiful. And right here, look at this. It's a nice Defender. Land Rover. That is very nice. I would not mind driving one of these. That looks like fun. And then you got this thing. This I've never seen before. Anybody know what this is? Oh, it's a Lancia. Interesting. Very, very nice. Almost looks like some kind of a rally car. Interesting choice of interior color, but I like it. It's different. Well, that was definitely a pretty cool collection of cars right here. Right on. Yeah. Alrighty. Back to work. Everybody keeps asking me why they leave the windows open on these cars. Guys, I have no idea. I don't work the side of the ramp. I have no clue. I just come visit and I just take a look at the cool cars. That is all. Enjoy the show. Next office. All right. This one just came up from the hangar and it's going to be leaving to Sydney later tonight. So we got to perform ETOPS check, but not the full-blown ETOPS check, only a partial, because half of it was done in the hangar and then we'll just finish up over here. We'll do the final portion of it. And the final portion is usually done 3 hours prior to departure. So do a quick little walk around and go upstairs. This is a Boeing 777-300, and what you're looking at there is the intake of the PAC system, or the air conditioning system, on the left hand side. But this is another component right there. Do you see that little smaller intake? That is called the RADA. Well, the acronym is RADA, Ram Air Door Actuator. It gives necessary force for positioning of the ram air door actuator for the NGS system, which is the nitrogen generating system. Fancy words for saying allowing enough air or sufficient amount of air to create within the nitrogen generating system of the fuel tank for the aircraft, which I've talked about many times before at this point. Little GE90 love. Ain't she beautiful? I know I always say it, but I can never help myself. It's a gorgeous engine. Okay, pay attention to this. So this is a 777-300. The 200 also has this. Do you see that little arrow that's pointing to a very specific fastener? There's another one coinciding right on the aft edge of that wing. There's multiple of these. Guess what? I have no idea why these things are there. Trust me, I have looked up and down and researched through all of the manuals. Trust me, I even got the part numbers for the sticker itself, or the placard for the arrow, but I do not have any clue why these arrows are pointing to this specific fastener or rivet. The internet, this is the part where I tell you, go, be free, and you tell me what this is, because I have no clue. You need to teach me at this point. Anybody that is a Boeing engineer or anybody that is a extreme aviation enthusiasts that have extensive knowledge on the 777 more than I do, please help me understand why these little arrows are pointing to that specific fastener or those specific fasteners, because I have no clue. I could not find it at all. Even talking to some friends of mine that are at Boeing, they don't even know. So help me out here, man. My best guess is some kind of a specific fastener for a spar. That's about it. Well, anyway, regardless of that, we're going to keep on going with our walk around. We're going to check the tires and brakes, the usual. We want to make sure the aircraft is good to go for an international flight for ETOPS. Okay, let's see now. My partner's gonna handle the rest of the outside, and I'm gonna take care of the inside. So, like I said, I'm just gonna go through the parameters, make sure everything's A-okay. No faults, no messages. That's exactly the way I like it. Get this thing ready to go. What you're seeing me do there is inspect the door bottle or the door slide bottle as well as the door assist bottle, making sure they're at nominal pressures. Quick little look to the cabin, make sure everything's okay and everything's in its right place. This is a 777-300 if you were wondering. So our configuration is, let's see now, 3, 4, 3. Let's make sure the bassinets are here. Yes, they're here. Good. Now, since we're here, let me show you how it works. I've shown you guys how the bassinets work, right? And this is for the babies. So we put infants in here when they go flying. Like that. And there's also arms that get down right here. There you go. That's your bassinet. Zip the little one in here. That's it. So parents don't have to hold their children. Very convenient. I can't remember who asked to see this, but oh, there you go. Somebody wanted to see the crew sleeping area on a 777-300. It's right up here. It's all the way in the back. It's above the cabin. So downstairs is where you sit. This is above the cabin. 8 bunks. And it's not very height-wise. I have to tilt my head just to walk through here, but it's still pretty good. There you go. And they got everything they need. Climate control, they have power ports, they got mirrors, lights, smoke detectors, all sorts of fun stuff. Yeah, there you go. And coat hangers. I'll put this over here somewhere. Alrighty. And obviously emergency equipment. Don't worry, I'm not going to leave you hanging. This is the flight crew quarters. So this is where the pilots sleep. This is right behind the forward galley. So a couple of steps away from the flight deck. You walk into this, there's a secure door. You get in here. The 777 has 2 lazy boys right there and 2 crew bunks right there where pilots can sleep. If you guys didn't know, pilots take shifts on long haul flights. The pilots have the same amenities, actually a little bit more fancy because they do have entertainment amenities. They have an in-flight entertainment service, as you can see that with the screens. But overall, I hope whoever was asking, there you go. Those are the flight crew quarters on the 777. This is the end of this day. That's about it. Keep on going, on to the next day. Let's go. Okay, that was a nice fun day. Hope you guys enjoyed it. We got to see a cool airplane, got to see some cool cars. I'm gonna go get some rest and I'll see you bright and early in the morning. Don't forget to copy. Later. Good morning, everybody. You ready? Let's go. First on the menu, Plastic Princess. This is called a flaperon. It's part of the aileron and flaperon control system. To be more specific, it's for the roll control of the aircraft. It can serve as three functions. Number one, primary roll control around the aircraft's longitudinal axis, move down or droop, as you can see it right there, to help high lift systems, or move up on the ground for speed brake operations. The 777 has the exact same thing. Good, looking good. So, first item on the menu, let's see now. Apparently somebody needed some oxygen, so they used an oxygen bottle. My partner already went to go get the brand new bottle, but this is what they look like when they're full. But yeah, there's a bunch of these on board, so somebody needed a little bit of oxygen, so easy change, not a big deal. Comes with its own little mask, pre-packaged and everything, so good to go. That's gonna be an easy one. Wait for the parts. Until then, check out the parameters, make sure everything's okay. There we go. Yes. Next office. Back to the Airbus. Do a good little walk around. This is a quick turn. Oh, here's something fun for you. If you guys ever wondered how the aircraft knows that the cargo door is open or closed, well, it's got proximity switches like this. It also has another micro switch that's way up here. See it? There it is. And when the door comes down and closes, it mates with this. Basically letting the airplane know the cargo door is closed or open. There you go. Okay, so far so good. Everything is looking a-okay, except for one little item. Looks like a little kid didn't make it to the bathroom, so kind of soiled seatbelt just a bit. No worries. We'll get some parts, change that out, easy peasy. Otherwise, we're good. And there you go. Brand new seatbelt. Nice. See, the job took me 5 minutes to do. It's gonna take me like 15 minutes to find a reference for this. The paperwork, it's hilarious. It's okay, thank God for digital manuals. All right, on to the next one. Next office. This one just came in from DC and going right back out to Miami. Quick turn, once again. But everything looking good. All systems normal. Oh, look at that. You don't need that on anymore. Okay, why not? Let's talk about this. So, what is that little button that I'm pushing that says terrain on ND? ND standing for navigation display. So this is part of two systems, EGPWS, Enhanced Ground Proximity Warning System, and the other system is called TAWS, Terrain Awareness Warning System. Just to make you aware, there's multiple systems. I'm just trying to make this very simple. This thing also talks to TCAS, but in general, it gathers its data from the weather radar that's inside the radome. The point of this is to alert the crew in case of any kind of hazardous situation that's coming up ahead. Not only is the weather radar feeding the information of any kind of weather that's upcoming to the pilots, but it can also switch up to terrain if any kind of proximity warning is happening. So if the mountain is getting bigger and the trees are getting bigger, it's going to start screaming at you. When the aircraft is in flight, the weather radar is functioning and active, so it's producing lots of radiation. You don't want to be anywhere near the weather radar when it's working. It will microwave you and cook you inside out. But when the aircraft is on ground, that system is deactivated, and what you're seeing there, that image, is a snapshot. So the weather radar is not actually functioning, it just remembers and takes a snapshot. I really hope I explained this correctly, guys. This is a complicated system. But anyway, moving on. All right, engine oil is nicely serviced per pilot's request. Come on, let's go upstairs and play a little joke. This will be fun. Okay, before we go upstairs, I gotta let you know, guys, you have to have fun at work. You genuinely have to have fun at work. I mean, take your job seriously, but you have to enjoy what you do. Not only that, you gotta put enjoyment and smiles on people that are around you. It just makes it more fun that way. This was a little prank that I pulled, or this was a challenge actually from another pilot. It was hilarious. And he goes, do this to the next flight crew. And he gave me this picture. And man, oh man, it did not disappoint. We were all laughing. Okay, watch. You guys are going to crack up. All right, Captain. You want to check the oil, see how they look for you?
Yeah, I saw that you'd added a couple already. Crap, bud there, bud.
Okay, so normally...
I appreciate you doing that.
No worries.
Those are squared away.
And here, if you don't mind, do me a favor.
Yeah.
Here you go.
What you got? What am I doing?
Give me a tip. You know, I live for these moments. These are the fun moments. I mean, getting an airplane out on time and getting it airworthy is great, but having this kind of enjoyment and laughter, it's the best. I love it. Okay, while we're waiting around for the next flight, it'll be here in about 30 minutes. I completely forgot. I got a little package the other day from this company called X Infrared. So apparently, there's a little gadget that you attach to the power port of the phone, and you get infrared. Pretty cool. Let's test it out. Just to let you guys know, this is not an advertisement of any sort. I don't get paid for any of this. I just like to use new tools or new technology, and I like to share it with you. So as I said, this is an infrared device. It is the P2 Pro model, and it says on their website, this is the world's smallest thermal camera. It attaches to the bottom of your phone where the power port goes. They have one for iPhones and Android. And don't worry, I'm not one of those that's not going to give you the price. I'll tell you exactly how much it costs. It costs about $250. Put that there. We'll read the instructions. I think there's a operating system you might have to download, but let's see now. Oh, look at that! That's cool. Let's see. I don't know how this works. I gotta learn how to work it. But you attach that to the back of the phone, and it's supposed to work. I don't know. Let me go through the instructions. Oh, here we go. Here we go. After messing with it for a while and reading the instructions, I finally found out that's actually a macro lens for the device. But anyway, let's check it out. Let's see how it looks when the thermal imagery is on. There's multiple features and functions to it. I can't go through them all. There's a lot of them. Feel free to go visit their website, which is xinfrared.com, and you guys can see all the specs. Now, to let you know, aircraft maintenance, we already have tooling like this that's very specialized, but the tooling is not as compact as this. This is more of a handheld, quick-to-go device. It can take a broad spectrum of analysis or temperature readings from every portion right there. As you can see, it's constantly scanning, but you can also have a mode where you can pinpoint exactly where to look. What you're looking at there is the oil tank of the engine, and look how hot the oil gets, or the components. Temperature-wise, I think it was pretty accurate. I mean, majority of it I put my hands on. Yeah, it's pretty accurate. Obviously, I'm not going to put my hands on something that's 150 or 200 degrees. That's the exhaust of the engine, the hot section. One thing to note, you can't point directly at a very hot source. This will start happening right here. It will go blank out. It's some kind of a thermal overheat protection within the camera, so you can't point at something super hot for a prolonged amount of time. You kind of have to point it off to the side. So you ask yourself, well, why would I need something like this in my line of work? Now, it's a handy little tool that can provide vital information. For example, if I walk up to a brake or a tire and I know I need to change it, I can right there, I can see the temperature of that tire or the brake, making sure that it's nominal temperature where I can actually work on it. If it's too hot, I can wait. And yes, the aircraft also has its own brake temperature monitoring system, but this is a quick reference. Like I said, it's a handy tool. We keep moving, and I'm going to show you here the exhaust ports of the air conditioning system, and look at the heat that's coming out of there. This is when you see me sometimes. I'm standing underneath the aircraft and it's cold sometimes outside. We'll stand underneath there, get warm, but don't put your face in there or hands in there. It is hot, and that's pretty accurate right there. It's a good troubleshooting tool, not an extensive, heavy-duty tool. There are specialized tooling, as I said, for this, but it's a good quick reference tool for troubleshooting. Discovering something like a leak within a duct, or if there's some kind of an unknown source of hydraulic fluid that is coming out, and hydraulic fluid is usually very hot when it comes out because actuators are moving. By no means this thing is calibrated or certified by any kind of governing body such as FAA and whatnot. So again, it's a personal little tool you can utilize. This was actually pretty cool. Check out those little circles right there. That's the static ports, and the static ports are heated. As we keep moving forward, you see those glowing things right there, those pipes? Those are the pitot tubes. They're also heated. And here's me cycling through the various modes. There's different color schemes that it can go through. The camera has a picture mode as well as a video mode. As you can see, I'm playing with the video mode right here. You can record all the things that you're seeing through the camera. Here's another good example of within the cabin of a 777. And you can see that the seats, they're pretty hot, hotter than the vents. This is me opening up one of the air conditioning vents, or the gasper, and you can see the transition. Cold air is coming out. Overall, I think it's a really good gadget. It's fun to use. Again, for quick reference, for just personal use. Nothing official, nothing calibrated, but yeah. If you're into this kind of stuff and you think you can get use out of it, pick one up for yourself. I mean, for its price and for what it can do, its capability, I think it's pretty good. But that's it. That's about the gist of this tool, and I'm glad I could share it with you. Anyway, back to work. So what did you guys think? Pretty cool, huh? All the infrared that you were seeing, it's all the backlighting, all those little dots, the source of light. Isn't that cool? Anyway, this thing actually is gonna stay here for a while, so just turn the APU off. I'm gonna sit in, doesn't leave until 8 o'clock, so it's a couple hours. No need to run the APU and burn fuel for no reason. But yeah, that's about it. Otherwise, it's a good bird. Let's go, on to the next one. Yep. Oh my goodness. Okay. Messed up tray table. Can you believe it? Just to take this whole thing apart, you gotta get all this hardware out. This is nuts. Sometimes they over-engineer this stuff so much. That's the cover. So, what I'm here for, oh yeah, by the way, that's what it looks like. What I'm here for, you're not gonna believe it, is these little adjustments right here. These little adjustments. That's it. Because the tray table is leaning too much. And that's the adjustment. You gotta take all that apart, adjust those to get it back up straight. Oh well. Now, I've said this before and I'll say it again. Majority of things that actually break within aircraft is not the aircraft itself or the important things. It's mostly the interior. The interior of the aircraft takes the most punishment. That airplane can fly nonstop all around the world without even a hiccup. But tray tables, carpets, seats, lights, you name it, that's what takes the most wear and tear. So most of the write-ups that I get are interior cabin items, or the dreaded either chapter 38, toilets, or chapter 44, entertainment system. That's just, that turns into a headache. But the aircraft itself, the flying portion of it, where it needs to function properly, it does just fine. It can go nonstop, keep on flying, not even a single problem. Not to say that aircraft don't malfunction. Yes, you do have mechanical malfunctions, but it's very rare. Well, in any case, I'm going to speed this up a bit so we can go faster because this was way too long. There you go, all back together. Perfect. Turning into a rerun of last week. I gotta service hydraulics again. Oh man, that's all right. Let me know. Let's see now. There you go. That's exactly how I want it. Beautiful. Had a bunch of other write-ups. Did not get a chance to film that, but it's okay. This one's almost ready to go. Oh yeah, before we forget. Since we're here, let me show you some of the maintenance menus that I go through to check some of the parameters. One thing we check for is IDG oil levels and backup generator oil levels, making sure it says normal right there. IDG standing for integrated drive generator. We can check hydraulics in more in-depth parameters, as you can see right there. Taking a look at the tire pressures, which is available on this aircraft. And we can even take a look at the APU oil levels and all the parameters that are associated with it. A quick look at the glare shield. That's the EFIS panel, Electronic Flight Instrument System. This panel gives pilots the function to select or certain control modes, ranges, and data displays on their PFD, their primary flight display, as well as the ND, the navigational display. Modes such as ROSE, ILS, VOR, NAV, certain barometric settings. A pilot would explain this better than I could, so I'm trying my best. Up next is the mode control panel. So this is a very important panel, and majority of the time, this is what pilots are manipulating to fly the aircraft. On the flight director, taking the auto throttle to arm or to disarm, autopilot engage or disengage, setting your vertical speed, your heading, aircraft speed itself, dialing in the type of altitude they want to be in. So as you can see, a very important piece of the aircraft. Now when it comes down to maintenance, my job, this is the panel I deal with the most. This is called the display panel selector. Remember when I keep saying I go through the parameters? This is how I'm able to do it. Watch. I'll go and cycle through all the pages. It gives me a plethora of information on what the aircraft is doing. Pilots also use this as well because they have a checklist, which I will show you later on a 787. It's pretty cool. But overall, this is how we interface with the aircraft, and when we pull up status pages, allowing us to understand what the aircraft is doing. There she goes, off to Heathrow. That's it. That was the last flight of the night, guys. Time to go home. I will see you bright and early in the morning. Later. Good morning, everybody. Whew, a little brisk this morning. It's okay. It's going to be a beautiful day. Let's go. Time for more fun. One more day. Welcome to Starship Enterprise. All right. This one's ready to go. Let's go to Dallas. Hey, quick little walk around. There you go, a little bit of Rolls-Royce action for you. I'm sure I mentioned this one before. See that hole right there? And that one? That's for the electronic engine control unit cooling. That's the intake. And that's the exhaust. Pretty clever design, ain't it? A little more context. This is a Rolls-Royce Trent 800 engine, which you saw right there. And that's what it's cooling. See that big black box? Inside of that big black box is the EEC. That's what needs to be cooled. These things are preconditioned air. So if the APU is not running, you'll get nice cold air from that big refrigeration unit right there. And on the right side right here, this is if you wanted to test your nitrogen generating system. It's a little control box where you can do a bite check. Built-in test equipment. And all sorts of fun ducting up here and wiring. Here's a nice little picture that was on the access door. It gives you an idea of how the nitrogen system or the nitrogen generating system routes all its air, as well as some of the components that are associated with the system. Next office. Now you ask yourself, Stig, why are you going up on a fueling ladder? Because the fueling panel needs to be retaped. Yes, speed tape. So in order to get this done, we gotta take this off, let the fueler finish fueling, then I gotta reapply the speed tape. Yes, it's legal, don't worry, it's fine. If I can get the darn tape off. It's coming out like this. All right. I think I've lost count on how many times I've talked about speed tape, and I still see people putting out misinformation out there and freaking out. This is not duct tape. This is not HVAC tape. This is speed tape. Yes, it is made out of aluminum, but it has a very strong adhesive to it as well. And these things are not holding the airplane together. This tape is not holding the airplane together. We use this tape to cover up any kind of deteriorating aerodynamic panels. Or if a panel, let's say, such as this one, which had a broken latch, this is a fuel panel, by the way, the broken latch, right there, as you can see, was only one of the latches. There's two more latches that's holding on. But in legality, we still need to secure that panel just in case those two other latches fail. Now you're going to say, well, why don't you just change the panel? Or why don't you just change the latch, put a new one? Parts. I need parts. I don't have parts at the moment. But this is a legal way to dispatch the aircraft. You don't believe me? You can look it up yourself on FAA.gov. They have a specific chapter just for this that talks about MELs, NEFs, CDLs. This would fall under CDL, Configuration Deviation List. It's approved to defer items such as this according to those manuals. It's approved by the manufacturer and approved by the FAA and the ICAO. So when you see mechanics out there putting tape onto the aircraft, please do not panic. We're not holding the airplane's wings together with tape. What we're actually trying to do is get you out on time and safe. I would say about 90 to 95% of aircraft flying right now have speed tape on them. But anyway, I hope you guys understand. Point being here is the fueler got done fueling the aircraft because they needed the panel open. I pulled the old tape off, let them fuel the aircraft. Once they were done, I retaped the panel. Now this is going to happen on every single flight. A mechanic has to go out there, pull the tape, and then reapply the tape. Once the aircraft is scheduled to go to a station with overnight maintenance, the parts will also be sent to that station. And that's when they will fix that latch and completely pull the tape off, and that's it. Back to normal. You can see this tape applied onto engine cowlings, certain portions of the airframe, but once again, just cosmetic aerodynamic panels. Nothing got to do with safety of flight at all. I'm convinced one of these days a passenger is going to film me doing this and I'm going to turn into a meme. I'll be all over the internet.
Thanks, Thomas.
Here's a fun one for you. So let's say you're in a restroom and you hit the call button, right? And guess what? Not only is it gonna ding in here, you're also gonna get this little light up here to notify the flight attendants. Pretty cool, huh? Press the button to reset. Bam. And that's a toilet. And of course, my favorite. Magic. Somebody wanted to see the cameras on the 777-300. Here you go. Here's the camera button, cam. The 200 don't have these, our 200s don't have these, but our 300s have these. And there it is. There's 3 cameras. One on the belly pointing towards the nose and 2 on the horizontal stabilizer, one on each side. Let's go downstairs, I'll show you. The official name for these is GMCS, Ground Maneuvering Camera System. Since the aircraft is so massive, these cameras are placed in a very strategic location, such as this one on a belly, pointing at the nose of the aircraft. During taxi operations, this helps the pilots guide the aircraft in the correct direction, or stay on the line. As mentioned earlier, there's 2 more cameras on the horizontal stabilizer, one on each side. These 2 cameras point down at the main landing gear as well as the aft portion of the flaps. The units themselves are actually encapsulated in a pressurized vessel. It has a sapphire window, and they are also heated to prevent any kind of ice buildup. Well, we're almost done over here. Just finished up the inside. My partner's going to finish up the downstairs. It's a happy airplane. And back to the beautiful 787. This one just came in from Philly. It's gonna stay here overnight. That's pretty nice. Just give it a little bit of oil. Check the parameters. You know, one thing I've never shown you guys, which is kind of cool, and this is mostly pilot stuff, so I'm not too familiar with it. I'll use a little trackpad here. You know, they follow a very particular checklist. Check this out. It's actually pretty cool. It's everything that they have to perform, all their duties before start. Let's see now. After start, before takeoff, just it gives them step-by-step instructions on what to do. Even after takeoff, in cruise and descent, the pilots are always doing something. When you're on modern aircrafts like this, everything has become digitized and computerized. Now they're using the aircraft interface to go through the checklists. If you go to something older, such as a 737, they still have handheld checklists. Once again, this is more of pilots' information, so anybody that's a 787 pilot or 777 pilot, because 777s also have this, Please go ahead. Feel free to mention what your duties are when you're in cruise, when you're in flight, descent. You know, all of these things have to be, from my understanding, all these things have to be checked off, and they're supposed to be green in order for you to proceed to the next step. Otherwise, you have a whole different set of instructions or, I guess, responsibilities to perform. But I just want to give you guys a quick little feature and show you, what the airplane is capable of doing. Anyway, I thought it was pretty cool. And I don't know if I've shown you guys this before. This is pretty cool. 787 has a towing feature, towing power. So right here, this is a battery test switch, making sure the battery has proper voltage. But let's say the aircraft is being towed with no power at all, and you can only tow it with battery power. You would hit this button right here. Just basically do that. Let me explain in a little bit more detail of what this actually does. Once you engage that switch, now you're putting both the main battery and the APU battery online. You only get very limited functionality out of the aircraft because you are towing without any kind of official power, as in no APU power. Here is what only gets power: left audio control panel and flight interphone, flight deck dome lights, wing and tail position lights, brakes, because remember, 787 has electric brakes, so you need power. The battery test switch, or the lights, high, medium, and low, because you want to know how much juice you got left in your battery. And that's about it. Pretty cool. I think that pretty much wraps it up for the weekend shift. I hope you guys all enjoyed it. I'm sorry if I did not get to your question on this video. Hopefully I'll get it on the next one. It's always a lot to talk about, but I try my best. Well, finally the day came to an end. Man, that was a long day. Hope you guys all had fun. Time for me to go home and get some rest. I'll see you guys on the next adventure. Later! Thank you all once again for watching, taking your time and leaving down questions and also educating me with your knowledge. I appreciate every single one of you. I'll leave you with this beautiful 747 taking off. Take care of yourselves, and I'll see you all on the next adventure. Later!